Hi, my name is Irene Lee, and this is my Lab 5 presentation. So, in this lab, we will be dropping a paper ball and an expo marker from the same height at the same time. To see which hits the ground faster, we will use the tracker software to track these objects' paths for accurate data. So, the purpose of this lab is to see how air resistance affects an object in motion, and then using the energy principle, we will be able to calculate initial and final kinetic energies to see if the internal energy is conserved or not. So, if it isn't conserved, then the internal energy is lost from air resistance. The system would be the paper ball and marker, and then the surroundings would be the earth. And then here you can see we use the tracker for the paper ball, and then we also used it for the expo marker. And then here's just some graphical data that we generated. So to the left is a graph that shows the marker versus time. And then to the right is a graph showing the paper ball versus time. And then here are our initial conditions. So h would equal 1. The velocity of the ball and marker are both 0. And then the kinetic energy of both are also 0. And then UG of the marker and ball, which are the same mass, is equal to MGH, which is equal to 9.8. And then here are the final conditions that we got. So h would equal 0, velocity of the ball is negative 3.07, and then the velocity of the marker turned out to be negative 4.43. And then the kinetic energy of the ball, we got 4.71. And then the kinetic energy of the marker, we got to be 9.81. And then UG of the ball and marker are both 0. And then here's the change in energy that we calculated. So to start, the formula is Kf plus Uf minus K initial plus U initial. And then for the marker, we got 0, which means there's conservation of energy. And then for the ball, we got negative 5.1, which means there was a loss of 5.1 joules of energy. So here is the physical significance of this lab. So based on the previous slide, we saw that the internal energy of the paper ball was not conserved, while the internal energy of the marker was conserved. So it took the paper ball a longer time to reach the ground than the expo marker due to air resistance. And then the resistance force also decreased the internal energy of the paper ball, which then explains that the charge in kinetic and potential energies. And then the what if question. So the first question is, what if the resistant force was friction instead of air resistance? So the object would still experience a loss in internal energy due to the force in the surroundings acting on the object. So for the energy principle to be conserved, work in the surroundings need to equal 0. So when the work in the surroundings is not 0, there is actually a gain or a loss of energy in the system. And then the second question is, what if the objects were of different mass? So to answer that, we would still observe the same results because mass does not have an effect on the time it takes for an object to fall. So, in other words, g is constant for all other objects near the Earth's surface. So, to conclude, objects that experience a resistance force will experience a loss in internal energy as well.